polyether complexes of alkali metals. Polyether complexes of alkali metals. Okay. Crown ethers and crypts. Crown ethers and crypts. Alkali metals form complexes with polyethers and crypts with macrocyclic molecules with nitrogen and oxygen. The crown ethers are first synthesized by Pedersen in 1967. Okay, the polyether complexes of alkali metals are such type of complexes which contain macrocyclic ligands. The alkali metals is situated at the center and shape of complexes is like a crown which is non-planar elliptical. Hence, these are called crown complexes. Dibenge 18 crown 6 and benzo 15 crown 5 etc. Okay? Alkali metals form complexes with alkali metals form complexes with polyethers. Form complexes with polyethers. And crypts with macrocyclic molecules. With macrocyclic, not microcyclic, macrocyclic molecules. Okay, molecules with nitrogen and oxygen. With nitrogen and oxygen. Okay, the crown ether are first synthesized by the crown ethers are first synthesized by Pedersen in 1967. Okay. Polyether complexes of alkali metals. Polyether complexes of alkali metals. Crown ethers and crypts. Okay. Alkali metals form complexes with polyethers. And crypts with macrocyclic molecules with nitrogen and oxygen. Okay, the crown ethers are first synthesized by Pedersen in 1967. The polyether complexes of alkali metals are such type of complexes which contain macrocyclic ligands. Okay, the alkali metals is situated at the center and the shape of the complexes is like a crown which is non-planar elliptical. Hence, these are called crown complexes. Dibenzo 18 crown 6 and benzo 15 crown. Okay. The alkali metals is situated at the center. The alkali metals, the alkali metals is situated at the center. Is situated at the center. Situated at the center, and the shape of the complexes and the shape of the complexes shape of the complexes which contain macrocyclic which contain macrocyclic ligands. The alkali metals is situated at the center, and shape of the complexes is like a crown which is non-planar. A crown which is non-planar, which is non-planar, okay, elliptical, non-planar, elliptical. Hence these are called crown complexes. These are called crown complexes. Okay, is the dibenzo 18. Dibenzo 18, crown 6, and benzo 15, crown 5, etc. Okay, and you can show this figure. Oxygen, okay, this is the dibenzo 18, crown 6. This is dibenzo. This is dibenzo 18 and the crown 6 and crown 6. 1, 2, 3, 4, 5, 6 crown and the dibenzo 18. Dibenzo 18 and crown 6. Okay, and next is benzo 15. Oxygen, okay. This is benzo 15 crown 5. 1 2 3 4 5. Okay, this is the benzo 15 crown 5, and this is benzo 18 crown 6. Benzo 18 crown 6. Okay, and this is the structure of some crown ethers. This is the structure of some crown ethers. Okay, in name of crown complexes, the figure 18 or 15 written before the word crown represent the number of atoms in a heterocyclic, and the figures written after the word crown 6 or 5 represents the number of ethereal oxygen atoms. Okay, in the molecules. The molecule may have a naphthalene or other ring in place of benzene ring. Some typical crown ethers are, you can show, that is lithium 1 2 3 4. Okay, and this is okay, and some is sodium 1 2 3 4 5. Okay, some important examples of polyether crown complexes are given. You can show, first is 18 crown 6 potassium ethyl acetate enolate. Okay, first is 18 crown 6 potassium ethyl acetate enolate. Okay, second is sodium water benzo 15 crown 5 chloride. Second is sodium water benzo sodium water benzo 15 crown 5 chloride. Third is natural antibiotic monoctine nigericin etc. Okay, generally lithium ions form crown 4 complex, sodium ions form crown 5 complex, and potassium ion forms crown 6 complex. The complexes found by cyclic polyether are relatively more stable. Okay, generally, generally, lithium ion forms, ground 4 complexes, ground 4 complexes, okay, complexes are ground 4 complex, sodium ion forms ground 5 complex, sodium ion, forms ground 5 complex, ground 5 complex, ground 5 complex, and potassium and potassium and potassium potassium ion forms ground 6 complexes, ground 6 complexes. Okay, the complexes formed by cyclic polyether are relatively more stable. Okay, the crypts it is more stable. Okay, the complexes formed by cyclic polyether are relatively more stable. The complexes formed by cyclic polyether polyethers are relatively more stable, okay, the crypts cryptate complexes are macrocyclic molecules with nitrogen and oxygen, okay, with nitrogen and oxygen. The crypts are cryptate. The crypts are cryptate complexes are macrocyclic molecules, molecules with nitrogen and oxygen, okay. The crypts are three-dimensional crown ethers which contain nitrogen atoms which provide branching and act as extra donor sites in addition to the oxygen atoms. Okay. The cryptates are three-dimensional The cryptates are three-dimensional crown ethers, three-dimensional crown ethers which contain n atoms, which contain nitrogen atoms which provide branching and which provide branching and act as extra act as extra donor, act as extra donor sites in addition to the sites, extra donor sites in addition to the extra sites in the addition to the okay. The crypto are three dimensions which contain n atom which provide branching and act as extra donor sites in addition to the oxygen atom to bond to the oxygen atoms to bond to the alkali metals, okay, alkali metals, iron. These are called crypts because these are called crypts because these are called crypts because these wrap round and hide the cation hide the cations, okay. The cryptand you can show cryptand 222, that is nitrogen, oxygen, nitrogen, okay, that is oxygen and oxygen. Okay, that is oxygen and oxygen. Okay, this is the structure of cryptand. Cryptand 222 ligands. Okay. Then the cryptates are three-dimensional crown ethers which contain nitrogen atoms, which provide branching and act as extra donor sites in addition to the oxygen atom to bonds to the alkali metals, ions. These are called cryptates because they wrap around and hide the cations. The cryptates 222, you can show this in this figure, okay. Thus the polydentate ligands such as crown ethers, you can show previous figure, and cryptates 4 form highly stable complexes with alkali metals. The ligands are highly selective in complex formation. Only those alkali metals ions which exactly fit in the hole form stable complexes in crown ethers. Donor oxygen atoms point towards metal atoms, which has been shown in the previous figure, okay. Function of alkali metals in biosystems, biological importance of sodium and potassium.